What if we discovered an alien civilization less advanced than our own? One frequent theme that comes up is the issue of what we would do if we found intelligent life on a planet around another star. What would we do if we found an Earth-like planet with intelligent life that is 500 years behind us in technology and advancements? It's not one question, really, but a whole set of nested questions. First, how will we find a truly Earth-like planet? Despite all the amazing recent discoveries of planets around other stars, astronomers have yet to find a true Earth twin. The closest they've come is a planet called Kepler 452b. It's roughly 5 times the mass of Earth and probably belongs to the class of planets called super-Earths. But not habitable like Earth. The same goes for the recently discovered Earth-size planets around the star TRAPPIST-1. These are extremely exciting worlds to study, and it is possible that some of them could support life. Second, how would we know if a superficially Earth-like planet is truly habitable? The leading method right now is to look at light streaming through the planet's atmosphere when it passes between us and the star. That's an extremely difficult task even for giant planets. Right now, we don't have the technology to do it. Another approach is to search directly for other Earths alongside their stars, and then analyze their light. To do that, you need both a very powerful telescope and a highly effective way to block out the glare of the star, since an Earth-like planet would be right alongside it in the sky, but on the order of 1 billion times fainter. That will take improved telescopes that are unlikely to be built at least until the 2030s. Third, how would we know if there's intelligent life on the planet? Proving the presence of any kind of life will be hugely challenging, even after we get past steps 1 and 2 above. Astronomers will analyze the atmospheres of the planets looking for biosignatures, unusual, out-of-balance chemical compositions such as those associated with life on Earth. SETI searches focus on possible signals sent by alien civilizations, but aliens with 16th-century technology won't be beaming us any radio messages. We'd have to find them in more subtle ways. Fourth, what would we do if we really found rock-solid evidence of a pre-industrial civilization on a planet around another star? We couldn't communicate with them by any currently known method. Unless physicists make some kind of wildly unanticipated new discovery, there is no practical way that humans could travel there, either. Potentially we could send miniature interstellar probes to examine the planet and learn more about its inhabitants. A project called Breakthrough Starshot is exploring the kind of technology needed to do something like that. Such probes would be so small and speedy that the aliens there would have no idea they were being watched. Let's assume next decade we find a potentially Earth-like planet around Alpha Centauri. In the 2030s we find plausible biosignatures on one of these nearby exoplanets. In the 2050s we image the planet and see plausible indications of an intelligent civilization. We launch interstellar probes there, which arrive in the 2090s. By 2100, we're convinced not only that the planet is inhabited, but that it is home to an advanced, semi-industrial civilization. Then finally we could use interstellar probes to drop coded messages all over the planet. Maybe the inhabitants could respond by setting huge